Good morning, everyone.
Good morning.
Is the screen and voice clear?
Yes, sir.
Yes, sir.
So good morning all. This will be the last lecture for module 1 now. So up to the session that has been covered in this class will be there for your module 1 examination that is slated to be conducted from 2 p.m. onwards. Okay. Yeah. So the last module or the last topic of the first module, the conversions of output machines. So in the previous session, we have seen Moore and Mealy machine, the two easy concepts. Given the transition diagram, converting it into tuples tables, and the same vice versa, and as well as the input-output mapping. So given an input, what is the output, and given an output, what is the mapping. So the same can be appended to both the machines. Okay. So if the examiner wants to still stress more on the topics, there is a way for them. Always the examiners in the formal language and automata theory finds their own way to crush the questions, even for the easiest concept. So in the previous session, we have seen how easy the concepts are, but coming to the conversion, again, things get a bit complex. Okay. One conversion is very easy, but the other conversion is a bit typical, but not as typical as the previous non-output machines. Okay. So today's topic is the first one, Moore to Mealy conversion. So given a Moore machine, how to convert into the corresponding Mealy machine. Okay, so I will take the same example with a different output and input combination. Now, this is the Moore machine. So you can see output inside the state. If the output is inside, over the input arc, then it's a Mealy machine. That's the basic distinction. Okay. So given a Moore machine to us, we need to convert into the corresponding Mealy machine. Okay. So this is a very easy process. Let's see here. Step 1. Construct transition table. Okay, so this is the first step because the data inference is much easier from a table than a diagram. So given Moore to Mealy or Mealy to Moore, the first step you should do is construct a table for it. Okay, if the table is given directly, you can skip the step 1, but in most of the cases the transition diagram is given. Okay, so for the same, construct the table. So the Moore table is like this: state, inputs, what are the inputs? A and B, and the output field. Now Q0. So Q0 on A will be reaching Q0 itself. Q0 on B will be going to Q1. Okay. So for the state Q0, the output is 0. It's irrespective of the input because there is a Moore machine. Comes the state Q1. Q1 on A, it goes to Q0. Q1 on B goes to itself. So the output for the state Q1 is 1. Okay. Construct this table. Now step 2. Compute modified output function. Lambda dash. So previously we have seen lambda. So lambda of Q0 is 0. Lambda of Q1 is 1. This is the output function in the Moore machine, one of the tuple. Here we need to compute the modified output function, lambda dash. So what is this lambda dash? Very simple. So this lambda dash now take the format of Q0 and the input as well. Okay, now that's it. Instead of simply going with the state, here we add an input character as well. So Q0 input A going to Q0 and it's producing the output. Just append a small input character. That's the only difference. Could you kindly mute whoever is unmuted accidentally? Yeah. So Q0 on A, the output is 0. The same Q0 on B. One second, just I will write it the next state and the output format. That's why the conversion becomes easy. So Q0 on A is Q0 with output is 0. Q0 on B, Q1 0. So the same Q1 on A. So Q1 on A, Q0 with output 1. Same way Q1 on B, Q1 on B, Q1 with output 1. Okay. This is 0. Q1 on A, Q0. Okay. If you reach Q0, the output is 0. Q0 is 0. Q1, it's 1. 1 second. Okay. So Q0 on B, you reach Q1. The output at Q1 is 1. Okay. So this is the traditional lambda function. This column is lambda of state. The lambda Q0 is Q0. Lambda, sorry, here Q0, Q1, Q0, Q1. Okay. Just a split up. That's it. The same table I have just made a simple transition function. That's it. Now step 3. Construct Mealy table. That's it. The problem is done. So this is the more table. What will be the Mealy table? So it's same state 0, 1. But for input, we have a next state as well as output. For an input, we have a next state and output, right? This is the Mealy table. Q0. So Q0, sorry, the output are A and B, not 0 and 1. So A and Q0 on A. 1 second. Okay. So Q0 on A, the next state is Q0. The output you are getting is 0. The same way Q0 on B, next state is Q1, 1. For state Q1 on A, the next state is Q0 with output 0. Q1 on B, the next state is Q1 with 1. That's it. For this table, construct the transition diagram. Okay. So the states Q0 and Q1, new states Q0 and Q1. As is a Mealy machine, the output should be corresponds to the input, right? So input and output go to Q0. That is Q0 on A with output 0 goes to Q0. I will write it as A by 0. Next, Q0 on B1 goes to Q1. So Q0 with input B producing output 1 goes to Q1. Q1 on A0 goes to Q0. Q1 on A0 or A by 0. The Q1 on A goes to Q0 with output 0. Q1 with B1 goes to Q1. Q1 with B1 goes to Q1. That's it. So this Moore machine is converted to the Mealy machine. Very simple step. You need to just stretch the
Sir,
table.
what is the difference then?
What is the?
What is the difference then, sir? Only the 0 which was there in Q0, it came to A, and 1 which was there in B.
That's what I'm about to come to the next one, Atharva. So in some competitive exams like GATE and other your placement exams, you don't have the luxury of doing all this step. I mean, this is for the descriptive format. If the question is asked in a descriptive format, you need to do all this stuff, which is unnecessary. Simply, as Atharva has said, a direct shortcut. In Mealy machine, the output won't be there in the state. It's simply it gets dependent to the input. So what I do is you just drag out 0 from inside of Q0 and append it to the arcs that are coming onto the Q0. You see this A coming onto Q0 0, this A coming onto Q0 0. So the same you can see here. In the same way, the output for Q1 is 1. Okay. So just remove it from the state and append it to the arcs that are coming onto Q1. So this B coming onto Q1, B by 1. This B coming onto Q1, B by 1. The same you can see. This is the shortcut. That's it. I have told you in the beginning, right? One conversion is dead easy and one conversion is a bit complex. This is the dead easy conversion. Okay. I hope all of you are clear with how to convert Murray to Mealy machine.
Yes, sir.
Yes, sir.
Okay, that's it, man. Just drag out the output, append it to the input that are coming onto the states. For this, you need to demonstrate all this thing. If the question is asked descriptive fashion, okay, simply don't draw these two diagrams and expect me to award the marks. If the question is asked as a descriptive, you need to spread all these flavors. Okay. So I hope no doubts with this Moore to Mealy conversion. Very, very easy. Okay. Now, a bit complex topic. The next one, the last topic of module 1, Mealy to Moore conversion. Just we'll break for 1 minute and I will proceed. Tess, what is the 2 to 2:45 hour today for you, ma?
CSD verbal.
CSD verbal. Okay. Who's the faculty?
Feroz, sir.
Feroz. Okay, Bhavya Rakshit, kindly forward the faculty's number to me, ma. If you happen to have his contact, kindly share it to me, else I will get from the department, ma. No issue. Okay. So the last topic of module 1, Mealy to Moore conversion. Just a second, guys. Okay. Yeah. So given a Mealy machine, we need to convert into the corresponding Moore machine. Okay. Yeah. So for this Mealy machine, you need to convert it to the corresponding Moore machine. Okay. So the step one is common. Compute the transition table. Okay. So we have a state. The inputs are 0 and 1 in this case, 0 and 1. And we have a next output. Next and output.
Sir, E and F, right?
No, input is 0 and 1, right, Atharva? Input. E and F are output.
Okay.
So state Q0. Q0 on E, you will be reaching Q0 and the output you are getting is E. Q0 on 1, you will be reaching Q1 and the output you are getting is F. The same Q1, state Q1 on 0. Q1 on 0, you will be reaching Q1 and the output you are generating is F. Q1 on 1, you will be reaching Q0 and the output you are getting is E. Yeah, that's it. Table is done. Step 2. There in Moore to Mealy conversion, step 2 is computation of the modified output function, lambda dash, right? Here, the reverse, we should compute modified input function, do dash. So there lambda dash, here do dash. I mean, if it's for the descriptive stuff. So here you need to have all this descriptive steps, else the solution it's bit tricky. So here there is no shortcuts, just like Moore to Mealy. We need to compute one by one because here again the states merging concept will be there. Okay, so we need to compute modified input function. So the modified input function is as follows: do dash of, for every state, I'll start with the first statement Q0 over an output and input. You should take like this. This is the syntax of the modified input function. Do dash of a state with an output and input, and it is nothing but transition of Q0 on 0, okay, comma, output of Q0 comma 0. This is how you should take for every state, for all the output and input combinations. So it's do dash of Q0 on E with 1, do dash of Q0 on F with 0, do dash of Q0 on F with 1. So you have to take like this. So for a state, for an output symbol and input symbol. So the all possible combinations of output and input you should take for a state. And the syntax is as follows. So for Q0 comma E on 0 means input of Q0 on 0 and output of Q0 on 0. Okay. So what is the thing? Q0 on 0. What is Q0 on 0? Q0 make a slash here now because we are going for the Moore states. So in Moore machine, the states will be like this, the state name by output. So what is the output of Q naught on 0? So Q naught on 0, you reach Q naught. What is the output there, ma? E. So you have to take it like this. Got it, all of you, ma?
Yes, sir.
Sir, once more.
Okay. So in Mealy to Moore conversion, this is the first step. For the given machine, you need to construct the table. So in most of the cases, diagram is given. If directly the table is given, fine. You can directly skip step 1. Step 2. Here you should compute the modified input function do dash. So the syntax is as follows. For every state, on every output and input combination, you should check. So I'm taking Q naught. This 4 corresponds to the state Q naught. So the combination of output and input, E on 0, E on 1, because E and F are the outputs, 0 and 1 are the inputs. So E on 0, E on 1, F on 0, F on 1. So while expanding the function, this is the nomenclature. So transition of Q naught on 0, because here while expanding, you can forget the output. Okay, Q naught on 0, transition of Q naught on 0, comma, output of Q naught on 0. For the same state and input combination, you should see what is the state it is going and where does the output it's getting. So Q naught on 0, refer the table, Q naught on 0, Q naught. While finishing the state, write it with a slash format, because in Moore machine, obviously we are converting this Mealy to Moore. So in Moore machine, the states will be like this, Q naught by with an output, right? So write like this. So Q naught on 0 is Q naught slash lambda of Q naught on 0. Lambda is output function, right? Q naught on 0. That means Q naught on 0, you reach Q naught now. What is the output? E by E, right? Like this. I will see for the second one, we will get a clarity. So this is transition of Q naught on 1, comma, output of Q naught on 1. What is Q naught on 1? The state is Q1 slash Q naught on 1, Q naught on 1, Q1. What is the output? F. So Q1 on F. Otherwise, is it clear?
Yes, sir.
All of you, Varun, Syed, everyone.
Yes, sir. Yes, sir.
Okay. Now you can carry on with the computation. So do Q naught on 0, lambda Q naught on 0. So Q naught on 0, the same itself now. Q naught by E. The same. Do Q naught on 1, lambda Q naught on 1. The same. Q1 by F. So Q naught is completed now. Take the case of Q1. So do dash of Q1 on E with 0. Q1 on E with 1. And again Q1 on F with 0 and Q1 on F with 1. The 4 you need to take. So Q1 on E with 0, I will write directly. Q1 on 0. Q1 on 0 is Q1 by Q1 on 0. Q1 on 0, which Q1 output is F. So this is F. Q1 on E with 1. So Q1 on E is Q1. Sorry, Q1 on 1. Q1 on 1. Q naught, and the output is E. Q1 on 0. Q1 on 0. The state is Q1. Q1 on 0. Q1, the output is F. So it is F. Q1 on F with 1. So Q1 on 1. Q1 on 1 is Q naught. Output is E. Okay. I'm just checking now. Q naught by E, Q1 by F, Q naught by E, Q1 by F, Q1 by F, Q naught by E, Q1 by F, Q naught by E. So these 4 corresponds to Q1. Okay. So that we have 8 input transitions. Okay. Now step 3. Should I make step 3? Okay. Now step 3. Construct more states or construct more machine states. Now, here you will be directly stepping on to the more table. So what is the more table? We have state, we have the input 0 and 1, and we have the output. Okay. So construction of more states. Okay. So how to construct the more states? It's simple. Actually, I mean, these are also the more states, but they are transitions. Here we construct the more states irrespective of this. Okay. So we have two, right? Two initial states in Mealy machine and two outputs. So you can expect 4 states. First state, Q0 with output E. And the next state is Q0 with output F. One more state is Q1 with output E, Q1 with output F. Now, if you compare the transitions to the states, there will be two things missing. You cannot see Q0F and Q1E in these transitions. Okay, only there will be Q0 with E and Q1 with F will be there. That will be repeated. This Q0 with F and Q1 will be, you cannot find in this transitions. But still, yet you need to take the more states. Okay, if there is a path, we'll represent it. Else, we'll just leave it as a dead state or something. But this is how you construct the more states. For every initial state of Mealy machine, with every possible combination of output, you have to construct a state. So Q0 with E, Q0 with F, Q1 with E, Q1 with F. Okay. Now, see the mapping. Q0 on E with 0. There you can see here. For all the states, you can see in this here. I mean, while the mapping, you can have a path. But on the RHS, you won't find the same state. That's the difference. So see, don't get confused. Very simple. Q0 on E with 0. So Q0 on E with 0. That's why I have written the syntax like this. Because at the time we reach the more state table, we require this sort of function. So even though the output E is not used in the function, but still we write like this because to have an advantage here. So Q0 on E with 0. Where are you reaching? Q0 on E, the same. All of you clear with the step 3 first point?
Yes.
Okay. So you need to construct the states as it is. For every possible state and output combination, you need to construct a state. And while mapping with the input, you have to follow the input function. Then Q0 on E with 1, Q0 on E with 1, Q1 on F. Now Q0 on F with 0, you can find it. Q0 on F with 0, that is Q0 on E. Q0 on F with 1, Q0 on F with 1, Q1 on F. Q1 on E with 0, Q1 on E with 0, Q1 on F. Q1 on E with 1, Q0 on E. Come to the last one. Q1 on F with 0, Q1 on F with 0, Q1 on F, right? Q1 on F. Q1 on F with 1, Q0 on. Now, input is mapped. Now, need to correspond the output. Okay. So, the same output, EF, EF. So, for Q0 on E, the output is E. For Q0 on F, the output is F. So, E and F. Okay. Now, based on the given data, we need to construct the Mealy machine, sorry, more machine. I'm converting here, see. Let's not make things clumsy. I'm just erasing it. Guys, all of you followed up to step 3?
Yes, sir.
It's a bit tricky, but not so complex. You can get terms with it. But not as easy as more to Mealy conversion. It's just direct one-step conversion. But here we need to work it out a little. Now take the states. What is the first state? Q naught on E. So write it like a Moore state. Q naught by E. Q naught by F. So Q naught by F. Q1 by E. Q1 by F. Now take the transitions. So Q naught on E on 0 goes to itself. Q naught on E on 1 goes to Q1 by F. That is 0. Q naught on F on 0 goes to Q naught on E. So this is Q naught on F on 0 goes to Q naught on E. Same Q naught on F on 1 goes to Q1 on F. This one. So Q naught on F on 1 reaches Q1 on F. Q1 on E on 0. Q1 on E on 0 goes to Q1 on F. So 0. Q1 on E on 1 goes to Q naught on E. This one. Last one. Q1 on F. This one goes on 0 goes to itself. So Q1 on F on 0 goes to itself. Q1 on F on 1 goes to Q naught on E. This one. You need not worry about the output now because the outputs are there in the states itself. Okay. So for this small little cute Mealy machine, if I were to construct Moore machine, this is the process. You can clearly observe Moore machine has more number of states than a Mealy machine. This is a very, very important a concept that can be asked directly as 1 mark MCQ. Which of the following output machines have more number of states? So it is always the Moore machine that has the more number of states. Mealy machine obviously has the less number of states. So the same goes with the DFA, NFA also. NFA obviously we have little states now, whereas DFA will have more number of states. Okay. So greater the complexity, greater the states now. Lesser the feasibility, the lesser the states. Okay. So this is the Mealy to Moore conversion. So I'm just reiterating from scratch now. Just see once. So you are given a Mealy machine. The step 1 is computation of transition table. So this is common for both. Or else I will make a comparative study. That's better. Moore to Mealy and Mealy to Moore conversion. Step 1, transition table. Here also the same given. For the given TD, obviously construct TT. That's better always. Second. So in Moore to Mealy construction, we compute lambda dash, modified output function. Here the reverse. In Mealy to Moore construction, we compute do dash, modified input function. This is output. This is input. So there are lambda dash syntax is very simple. So the lambda dash, it is state comma input. Is that it now? State comma input. For a state on input, what is the output? So this is the modified output function. So our input function, it is do dash of state comma output comma input combination. So it is transition of the state, same state on input and lambda of state on input. So this is the syntax you should remember. Okay. So we have seen Q naught E on 0. So it is Q naught on E, the same Q naught on E. Input of Q naught on E and we compute output of Q naught on E. Okay. This is how we do the function. So the step 3. Construct Mealy table. Here we have additional state, I mean the same construct more table with more states. Here also you can write the same point, construct Mealy table with Mealy states. Okay, that's it. Obviously you can reach the transition back. So while talking about the differences, more machine always has the higher number of states than the Mealy machine for a corresponding problem. Okay, not that always more state has a higher number of states than Mealy machine. That's not the thing. If you take a complex Mealy machine, obviously it will have a more number of states than a simple Moore machine. But for a corresponding problem, that's very important. The examiners even try to make the question tricky. For everything, like always the Moore state has highest number of states and all this thing. Not that. For a particular set of problem, okay, for a particular entity, always the Moore machine has more number of states than a Mealy machine. Okay. So simple distinction is in Moore machine, the states are like this. So it is state by output. Okay. And the input simply it has only input value. This is Moore first machine. In Mealy, Q0, the output binds across with input 0 by A. So they are like an inseparable pair in Mealy machine. So this is the main difference. Okay. Yeah. So module 1 is completed now.